Section 6.1 is about graphing quadratic functions. A quadratic function is an equation that looks like this, has this form. It has a squared term, we call that the quadratic term. It has a term with an exponent of 1, that's called the linear term. And then it has a number at the end, that's called a constant term. Now it is possible to have a quadratic function that doesn't have a b or a c, and it's just something x squared, but the other terms have names also, and that's what they're called. When you graph a quadratic function, you get a shape that's called a parabola. And a parabola looks like this. It can open up or it can open down. It looks like a U, either regular or upside down. That's called a parabola. Here we're asked to graph a quadratic function by making a table of values. So I'm going to make a table with x's and y's, and then I'm going to plug in a bunch of x's, find out what their y's are, and see if I can't graph this parabola. For no great reason, I'm going to start with -2. Those are typically the numbers that I like to start with. Plug them in for x and try to find their y's. So here I've put -2 in for x. -2 squared is 4. 4 times 2 is 8. -8 and -2 is plus 16. And then plus 9. So that's going to give me a 33 when I plug -2 in. Now, if you look at my graph is about a 10 by 10 wide. 33 is way too high. So I'm going to even skip -1 because I don't think -1 is going to be a number that's going to be close. So I'm going to try 0. This time I'm going to plug 0 in for x. And 0 is really a great x point because it cancels everything out. This becomes a 0, this becomes a 0, and you get 0, 9. That's a much more manageable point. So I'm going to go from here, and I'm actually going to increase my x's all the way down to 4 and see if I can't get about 5 points. I would suggest that you pause the video now and you plug in each one of these x values and try to figure out what y values go with them. So when we plug 1 in, we get 2 minus 8 is -6, plus 9 is 3. When we plug 2 in, 4 times 2 is 8. 8 minus 16 is -8, plus 9 is 1. Plug 3 in, you get 9 times 2 is 18, minus 24, -6, plus 9 is 3. And here we get 16 times 2 is 32. 8 times 4 is 32, so that's a 0 plus 9 is 9. So we're going to graph these 5 points, but if you notice these 5 points, something interesting happens. They each have a 9, they each share a 3 here, and then there's a 1. That's what happens when you graph parabolas. So let's take a look at what the picture shows us if we graph these points. So here are the 5 points, and hopefully you can see that it's a parabola, and it looks like this. And you need about 5 points to get a shape that looks like that, and you want to try to find the points that begin to repeat. Once you find these repeater points, you know you've found kind of the foundation of the parabola. Here's the key concept about quadratic functions. If you have a quadratic function, ax squared plus bx plus c, the letter c, the constant, is the y-intercept. That is the number or the place where the parabola is going to cross the y-axis. So if you plug 0 in for x, whatever you're left with is going to be your y-intercept, and that's going to be your c. The axis of symmetry, the line, in this case it's red, the line that cuts the parabola in half, slices it right down the middle, that's called the axis of symmetry. You can find that by using the formula x equals the opposite of b over 2a. And then finally the vertex is the point where the parabola begins. Either the vertex is at the bottom, like this, or the vertex could be at the top, like this one. But either way, the vertex can be found by plugging in the axis of symmetry for the x and then finding the y coordinate. So here we have a quadratic function, and we're asked to find a lot of things about that function. First things we're asked to find is the y-intercept, the axis of symmetry, and the vertex. Now before I do that, I want to take my quadratic function and I'm going to write it in descending order. So I want it to look like a quadratic. Remember, we want the squared term to be first, then the linear term, and then the constant. Now this also helps me to see a couple things. The number in front of the x squared term is my a. So in this case, my a value is a 1. I'm going to need that a little bit later. The number that's in front of the linear term, the x, is my b, so I can see that my b is an 8. And the constant term, the c, is a 9. So I can look at this parabola and see that a, b, and c are 1, 8, and 9. That's important because my y-intercept, I'm told by the key concept, is the 9. It's that c value. So I know that my parabola is going to cross the y-axis at 9. The second thing I'm asked to find is the axis of symmetry. Well, how do we find that? We use the formula. Opposite of b over 2a. So opposite of my b is 8 over 2 times a. My a in this quadratic function is a 1. So that's going to be a negative 4. So I'm told that my axis of symmetry is x equals negative 4. That's the second thing that I'm asked to find. And then the third is the vertex. Well, how do I find the vertex? I take negative 4 and I plug it in for x. And I solve this. This will be a 16. This will be a 32, which is negative 16 plus 9. So that's going to be a y value of negative 7. So my vertex is negative 4, negative 7. That's the third thing. So I found my y-intercept, 9. I found my axis of symmetry, negative 4. And I found my vertex, negative 4, negative 7. That gives me a good description of what the parabola is going to look like. Now I'm going to make a table of values that includes my vertex. Now because my vertex is in the middle, I'm going to put that in the middle. I'm going to use x values that are a little bit smaller than that and a little bit bigger than that and find out what their y's are. Now I know the vertex is negative 4, negative 7. I'm going to try negative 3 now. So I'm going to plug negative 3 into my original quadratic function. This will be 9 minus 24 plus 9, and that's going to give me negative 6. So I have an ordered pair, negative 3, negative 6. Now because this is a parabola, because we know that it's symmetrical, it's the same on the left and on the right, I know that there has to be a point on the other side of the vertex that also has a negative 6. So I don't have to do any work for negative 5. I know that this has to be negative 5, negative 6. Now I'm going to plug in negative 2 for my x. This will be a 4 minus 16 plus 9. That's going to give me a negative 3. And again, I know that because this is a parabola, there's going to be some symmetry. So that means the y-coordinate up here is also going to be negative 3. And now I'm going to graph these to make my parabola. So there's my parabola, what it looks like. I want to label a few things. I know that my axis of symmetry is here at x equals negative 4. So I'm going to use a red dotted line just to show that. That's the line that cuts the parabola in half. I know my vertex is negative 4, negative 7. That's the main point where the parabola begins. And even though it's not on here, I know that this parabola would cross my y-axis up here. If I were to continue this parabola, it's going to cross up here at 9, and I know that because my y-intercept was 9. Here's some more information about quadratic functions. If you have a quadratic function and the leading coefficient, the a, which means the number that comes in front of the x squared term, if that's positive, then you know that your parabola is going to open upward. And the vertex, the point at the very bottom, is going to be called a minimum because it's the lowest point on the parabola. Likewise, if your a is a negative, if the leading coefficient of the x squared term is negative, then your parabola is going to open like this, open downward. And then we know that the vertex is going to be a maximum point. It's going to be the highest point on the parabola. In this example, we're asked to consider this function and tell if it has a maximum or a minimum. Well, the quadratic function has an x squared term with a number in front of it of a 1, so my a value is going to be a 1. which means my a is positive. So in my mind, I know that my parabola is going to open something like this. It's going to open up, which means it's going to have a lowest point, so therefore it's going to have a minimum. Now to find that maximum or minimum, to actually find the value, we have to find the vertex. And to find the vertex, you first have to find the axis of symmetry. The formula for the axis of symmetry is opposite of b over 2a. In this problem, my b is a -4. So the opposite of -4 over 2 times my a, which I already know is a 1. That's going to give me a 4 over 2 or a 2. So my x value is a 2. I'm going to plug that back into the function and see what the y value is. So I'm taking the 2 and I'm plugging it back into the original function right down here. 4 minus 8 plus 9, so that's a -4 plus 9 is going to give me a 5. So by combining the x and the y together, I get a coordinate of 2, 5. I know that's my vertex, therefore I know that the 5 is my minimum value.